Thank you. So this is probably the most important talk you'll see in the entire show. And obviously. So the reason for this is if you're going to do Qt programming, you have got to understand this stuff. It is so important because Qt seems so easy to go to. You probably know C++ before you go there. You just read a bit of documentation, you get started, and things seem to be going along well. And that's okay. You can definitely get started with Qt that way. But you don't take advantage of all that these tools can actually do on a fundamental level. You don't consider what it means that you're doing Qt when it comes to your architecture and your design. And this is not rocket science. I'm pretty much only going to talk about signal slots and where that comes from. But I'm going to give you some ideas about how you should actually think about your architecture because of this. This does change things coming from regular standard C++. And you should know this so you can work with it. So before we start this, I will just mention this again. We have a competition at the Viking Software booth. You can win this. It's a small drone. It's really fast and it's fun. And you can. It has a C++ API. That's the thing. So these two lovely young men will walk around and collect business cards. And if you don't have a business card, there is something you can write on. So you can give us your name and email. And whoever wins this, if you're not at my talk later today at 4 o'clock here, then we'll ship it to you. So, Frederik, Jordi, walk around, collect. So, me. I run a company called Viking Software. We are doing Qt stuff because that's what I like. So when I started the company, I got to choose, and I chose Qt, of course, because I started doing Qt coding in March 1997, so 2 years and 7 months ago, 22 years and 7 months ago. That's a bit of time. I've been here a lot. I've probably done something like 100 different customer applications. So I actually know this stuff. So I don't know when I learned this stuff that I'm going to show you here. It probably crept up on me over the years. But so you get a lot of the experience that I've had over the years for free here, I hope. Well, you paid for being here, I guess. So this is what we're going to go through. I'll skip that because we have only 22 minutes left already. So QObject. Most of the stuff that's not a QObject in Qt are all the value classes like QRect and stuff like that. I do hear some non-Qt people say, yeah, we don't want a subclass Qt because there is a price to pay, and there is. It's about 40 bytes and a vtable. I don't care. If it's a QObject, then it's a QObject. Make it a QObject. So don't go into the hole of not making something a QObject because there is a price to pay. The price is so small that if it is a QObject, it should be a QObject, then make it a QObject. Because then you get these goodies. So signals and slots. This is obviously something that you've all heard about because this is fundamental to what Qt does. So let's just go over a bit of what it actually is. We have the defines here, up here on the left. Left, yes, which says define signals public. That used to say protected, which I still think it should do. So signals just do pretty much nothing. It just does, whenever you declare signals, you just get public methods. The thing about signals is that you don't implement it. The mock compiler does that. Let's take the next one, slots. Define slots, nothing. That means when you write slots, you write public slots, colon, and then your slots there. The slots just goes to nothing. And the idea is that this is only a hint to mock that it should do something with this. And I'll show you later what it actually does. Emit is the same. It is just an empty define. So why do we even use emit? Well, you don't have to. You can just write the signal name, and then it will work exactly like doing emit. It doesn't do anything at all. Mock doesn't do anything with emit. This is a note to self. It's a note to us that we don't know what happens when we emit a signal, and we shouldn't know, because there can be anything, anywhere from 0 to n slots connected to your signal, or even signals connected to your signal. So you don't know what happens there. Usually when you call a function, you know what that does. You know how long time it's going to take. You don't know that with a signal. That's what emit does. It tells us this is a signal. I actually don't know what happens here. And that's the only thing it sort of does. Oh, by the way, those who didn't go to my talk yesterday, I have pun jokes at the bottom of my slides. There is no reason for this. That's just a tradition, because my slides are incredibly boring. So I'll just add some jokes to them. They're probably not funny. At least I don't hear anyone really, I don't know, whatever. So signals and slots example. This is actually a really bad example, and I'll get to the right example on the next slide. But let's just stay with this one. So the idea is, you know this stuff. You connect one object to another object, from a slot to a signal to a slot, or a signal to a signal, and then stuff happens. Now, the reason this is a bad example is actually because there is a better way to do this specific one. It's not a bad example of what a signal and slot does. You just connect your standard visitor pattern slot to a signal, so whenever that signal is emitted, your slot gets called. It is a standard visitor pattern in that respect. Now, this exact example, the reason I say this place is not good is that this one is the first time I saw an example of a lambda slot where I thought, oh, this is what lambda slots are for. This is exactly the place. When you do network code and you send a request and the answer comes back, then it comes exactly to this point in the lambda code. And that's just so much simpler than just going to some slot and then trying to connect it to the place where that sent the request away. So you have, with the lambda slots, what you get extra over a standard slot is that you have a connection between what sent away something that needs a response and getting that response. So you have that connection between these two. You don't have that with a normal slot, usually, unless you only do one at a time, because then it doesn't matter. So I don't do a lot of lambda slots. This is not something I do all over the place. I actually do it very few places, and this is one of them, one of those that I think makes a lot of sense. So, properties. This is something that's not directly related to signals and slots, but it is anyway. So QProperty is again something that's just defined to nothing. It doesn't do anything in itself. What it does is to just tell mock, do something with this stuff. And actually, if you only write a C++ based code and you don't use Qt Designer, then a QProperty doesn't do anything at all. You don't get anything from it. You might as well just have the signals and the slots of this one, but with one exception. You can use the dynamic properties. I don't know if you know these dynamic properties, but you can just call set property and the name of this property and then set it with whatever value you have. I don't like them. I don't like dynamic properties unless I have to use them, but there are a few cases where you would use them, but mostly you don't. And the reason for that is that you can't see that they're there. When I look at code, I need to be able to understand what happens. And dynamic properties are something that's hidden. You can't see them anywhere. They're not declared somewhere. So I can't see that these exist, and I can't see what happens when they're used. And that's why I say, please don't use them if you can avoid them. But you are going to hit the dynamic properties when you see what's in the documentation and so on. So you should know that they are there. But yeah. So the one place where QProperty does make a difference is if you have integration with QML, for example. But we'll get to a slide later on that one. I'll just say here that this is what defines how you export stuff from C++ into QObject when it comes to the attributes or the properties. So if you do it on there was a talk yesterday about how you integrate stuff into Qt Designer if you do a Qt Designer plugin. And on that one, you can use these ones as well, because a property defined like this will show up in the editor if you've done a proper Qt Designer plugin. So you can use it for that. There is no downside to use this. So if you do have something that is a property, just get into the habit of writing that in the top of the QObject, because it's something that we see very easily when we see at a header. We look at a header file, we see the list of properties. Okay, easy. That's what I can manipulate with this object. So I've mentioned mock a couple of times. You all met mock before. And it's this weird thing that we have to use with Qt. I know that there are examples of getting rid of mock. Olivier Goffard have talked about doing Qt without mock, which basically does most of it using templates. But there are some things that you can do with mock that you can't do without it. And I don't care that we have to do a code generator that runs over our header files. I think it's fine, but I've been used to it for so many years that I don't mind it. It's something that if you go out there and you have to convince a standard C++ guy to use Qt, this is one of the things that they really complain about. And I think it's silly. It's such a small thing. So just say, what's the problem? I mean, just use it. I don't think it's a bad problem to have. Now, the last one there, dynamic method invocation, is probably not something you use a lot. Some of you may not even know what it is. It means, for example, if you get a text file sent to your application that says something would like something to happen. Dynamic method invocation is one of the things you can use to implement that. You read the text file, you say, oh, this object needs to have a function called. Then you call the function through what mock does. Actually, you do it with QMajorObject, but we'll get back to that one. So, the QObject. You've seen that. I told you it adds about 40 bytes to an object. And what's actually happened? How many here have looked into what is the define when you write QObject inside the file? Okay, 27.8%, brilliant. The rest of you should have done it. Now you're going to go home and do it, because I don't have the time to really go into what this says. What I'm attempting to do in this talk is to open the door for you to understand that this knowledge is worth having. So I'm giving you these examples of what I do when I really teach how does a QObject work. And when you're done here and you go back to your office, one of the things I would like you to do is to actually look up this define in the header of QObject and see what does it really say. What does it mean that I write Q_object as one of the first lines in my C++ class? It actually means this. It has a static const object, the meta object. It has a set of different methods. One of them is to get the meta object. Another one, there are a couple that has to do with casts. There is the translation thing. And that's sort of it. Those are the most important ones. So what does this mean for you? Well, this is what offers the translation stuff. When you do tr whatever, that's actually the method it calls. And these are the same for all QObjects, which is why it's implemented this way. The above one, the meta object, is not something that you use a lot when you do Qt programming. Not even if you're a many-year-old expert on this. QMajorObject is not something you do a lot of times. But occasionally, this is exactly what you need to solve some problems that you cannot solve with regular C++, because this allows you to get to the introspection of stuff, where you can say, okay, I have a QObject. What can that actually do for me? It has these list of properties. It has this list of methods that I can call, and so on. And the QMajorObject is what does that. So this is about a boring QObject class as you have ever seen, I guess. The only thing it has is a counter, and you can set it and you can read it. So this is a simple class, but it does give the example of what actually happens when you do this QObject macro. So the QObject macro inserts this QMajorObject. It inserts these method specifications that are all private, by the way. And then it adds the property definition, which is empty, so it doesn't do anything. Then it has the public. This is just the constructor and the getter method. The public slots, which when it's run through the precompiler just says public : and then the set count, and the signals, which says public : and by the way, the reason I say that I still think it's wrong that it was changed from public to private is that from protected to public is that I don't think another object should be able to emit a signal on my object. And the reason for this is these objects are supposed to be boxes that you can manipulate. You have the API, you have the setter methods, you have all the methods that you call on it. Whenever that happens, the internal state of the object changes, and that's when a signal should be emitted. I understand that sometimes you need to have this public method that just emit this signal, and then it emits its own signal. That used to be the case in old style Qt code, that we sometimes had to add this, but it was the correct way to do it because it's the object itself that knows if its state changes or not. So if you're about to call a signal on another object, you should have a small ping actually go up in your head that says, this might be a bad idea because I'm doing something that's architecturally wrong. But there are exceptions. So you'll probably remember, the only thing you're going to remember for this is I'm probably in one of the exceptions now and do it anyway. But try and avoid it. Parent-child relationship. The only thing I'm going to say is don't use smart pointers with QObjects. Ever, ever, ever. Maybe do it at the top of the inheritance, top of the object tree. Maybe. I would say get used to running Valgrind on your C++ code and check for these memory errors of deletes and when you forget to delete, and make sure that you don't do double deletes. Once you've done this for a year, you learn it. You learn how to control when to delete objects in C++, and then you do it the right way. Because I think in the current C++ world, there is a trend that, well, you can see that. There is a trend to going towards smart pointers. And the reason for that is that they all think we're all idiots who can't do our deletes at the right time. And I don't like that. I like to have control over when I actually delete an object. And the only time I use a smart pointer is when the ownership of something is shared. Because if you don't have a specific object that says, I own that object, then you don't know who's responsible for deleting it. And that's the point where you say, okay, now I can use a shared pointer because it's going around, and when no one has a pointer to it anymore, then it should be deleted. That's fine. That's what smart pointers are for. And for unique pointers, it's obviously different. Unique pointers I do like. So use QPointer instead, because there is one signal that QObject has. That's destroyed. Whenever a QObject is deleted, the last thing it does is, I'm going down. And then it emits destroyed. And this one, if you have put it in a QPointer, then it tells the QPointer it was destroyed. So the only thing QPointer does is not to avoid it being destroyed, but you can ask, is this one destroyed? So it's like a weak pointer. And that makes sense for Qt. But the reason you shouldn't put these in smart pointers is because if the parent is destroyed, it will kill all its children. That sounds really wrong. It will delete all of the things that you have set as child objects. And your smart pointers won't know that. So the smart pointers still think that it has an object to delete. I've ramped it, no, but don't do that. So QMajorObject, I mentioned that a while ago. The only thing pretty much I do with this one is occasionally call inherits. So I need to know if an object actually inherits another object. That one I like doing. The last two are really rare. The only place I used the new instance and dynamic method invocation was when I did sort of a object to object, a remote calling procedure thingy. I don't remember the name, RPI, whatever. Because there you have exactly the situation I mentioned. There is something that wants to call an object and you send some bytes or whatever that says call a method on that object. And this is the way you do it. You can instantiate objects with QMajorObject and you can invoke methods with it. It's handy and it's something that's really hard to do without any kind of a precompiler or a code generator. All the QObject or other things, whatever it's called today, use some kind of a precompiler or a code generator to do this exact trick. But with Qt, you get it because we already have a code generator in mock. QThreads, I'm not going to say a lot. I have a talk here in 2 hours where I go through QThreads. So let's skip those today and just do QML. So I am completely convinced that QML was designed by the guy who said, I'm fed up with writing all these properties and signals and slots and connects. I just want to have a property described like this. Another one says, I depend on that one. Done. Text file. Very short. This one. And I actually use this, that one colon, a lot more in QML than I use in C++ because I use this pattern all over the place. And if you were at my QML talk yesterday, that is one of the things that can lead to the QML binding explosion. But other than that, I really like this one. So all of the stuff that we've talked about here, the properties, the signals, the slots, the meta object, the dynamic invocation, this is what QML does internally. This is how it implements the things. So when they started, Nokia started doing the QML things about, 10 years ago, 12, something like that. Then that was very easy to implement because they already have the full technology to do it behind the scenes. They just needed to pass the text file, and then they already have everything else there. Then they needed to add JavaScript and all sorts of bad stuff, but whatever. So architecture stuff. This is the one where I actually teach you what you need to know here, I hope. The keyword here is black box. I want you to think of your object as black boxes where the public methods change the state of the object and the signals are what says my state was changed. That is what happens. And you should never do it in another way. I don't like that a QPush button, you can call it and say, I was clicked. No, you should call the click method because then it says, ooh, I was clicked. That's the proper way to do it. And think about that when you do your code. This is the important part of doing Qt code, that you have to go away from calling stuff when your state changes. This is what we used to do before Qt, if I can even remember that. So whenever your state changed before without Qt, you call something that needs to know my state changed. Don't do that with Qt. Just say my state changed. And then whatever has the connection between the two objects, I know this object, I know that object, this object state changed, that one needs to know, then this one does the connect. And then stuff happens there. But this object doesn't know that this needs to know its state change. And this is the change that QObject should give you. It's not only about giving you an easy access to a visitor pattern. It is about changing the way you think about objects in that way. So that is what I had time for. I have 27 seconds left. So if you have a super short question, we can do it. Come on. There's one right there.
In your previous slide, there's a point that says don't use introspection unless you have to.
Yes.
What are the downsides of using introspection all the time? For example, in QML code, instead of registering the type, you just like
introspection has a couple of problems. The biggest one is that you lose the compiler checks. So if you do a call by calling a method invocation on QMajorObject instead of calling the method directly, then you lose the check by the compiler, is this actually okay? That is the biggest problem with it. There is also some problems with your code being much more difficult to read. So introspection is something that there is a reason we don't do it a lot, and that is, there are very few cases where you actually really need it. Most of the time, you should just do direct method calls or signal slots instead.
Does it apply to QML side as well? So are you suggesting that you should register the type with QML and then call it, or you don't have to register the type past the QObject?
This is C++ only. For QML, I don't think introspection really makes sense to talk about, because the introspection stuff is what makes QML work. So in that case, it's not your problem if it works or not. So QML, one of the problems QML is that it isn't statically checked. So you need testing. And there's no way around that. Sure, you can do some unit testing by calling QML code, yes. But it's not that easy. So I would just say, when you do QML, and I know you do a lot of QML code, forget introspection, because you don't do it. You don't ask an object, what can you do, and then call that in QML. You just call it and assume it's there. Other questions?
Thank you very much, Bo.
Thank you for taking the time for me.